Now this question is from Newton's law. Question says a particle of mass m is at rest at the origin at t is equals to 0. So this is the initial condition given. At t is equals to 0, particle is at x is equals to 0. This is given. It is subjected to a force Ft, f naught e to the power minus bt. So it is subjected by a force that is basically a function of time. Force is not constant. Ft is equals to f naught e to the power minus bt. You see about this force is exponential. When t is equals to 0, force is f naught. When t is equals to infinite, this this goes 1 by this, so this number is almost 0, so force is 0. So what is happening when t is equals to 0? Force is f naught. When t tends to infinity, this number is e to the power minus infinity, that is 0. Force tends to 0. We have to find its speed as a function of time. So we can find velocity as a function of time. It is easy. So we can write acceleration, that is dv by dt. We know the first Newton's second law, force is equals to mass into acceleration. So acceleration is f by m, and acceleration is also written as dv by dt. So if I use this expression, that is f by m is equals to dv by dt. So we have written dv by dt is equals to f by m. F is f naught e to the power minus bt, and this divided by m. This will give you acceleration. So from here I can write dv is equals to f naught by m e to the power minus bt into dt. Now we can integrate this one to get the velocity at any time. T is equals to 0. T is equals to 0. This starts from rest. Mass is at rest. So T is equals to 0. Velocity is equals to 0. And T is equals to T. Velocity is V. So if we integrate, so V is equals to, so dV, integration of dV is V, f naught by m, and e to the power minus bt, so e to the power minus ax. Integration of this is simply to the power minus ax divided by minus a. So in this case we will have e to the power minus bt divided by minus v, and we have to integrate from 0 to t. So if I do this integration, v is equals to, let us take minus sign outside, f naught by m into b. When if I put t, this will be e to the power minus bt, and when I put 0, this is simply 0, so this is 1 minus 1. So this will be v is equals to f naught by mb 1 minus e to the power minus bt. So this will be the velocity as a function of time. We can plot this as a graph. So if I try to plot this graph, when t is equals to 0, velocity is f naught by mb. So this is the initial velocity. Oh sorry, when t is equals to 0, velocity is 0, because this is 0, so this term is 1, so velocity is 0. So I have certain expressions. When t is equals to 0, velocity is equals to 0. When t is equals to infinite, velocity is, this term is 0, because this is infinite, so this term is 0. Velocity is f naught by mb. So now it is easy to draw the graph. Maximum velocity at 10, let us say this is the maximum velocity, that is f naught by mb. Now this is 0 velocity, so what will happen? This graph will be something like asymptotic. When t is equals to infinite, this will reach to this line. So this kind of graph we will have, and that is the case in option number 2. f naught by mb. So I should have f naught by mb. Velocity is f naught by this intercept is f naught by mb. So in this case, answer is B. So option B is this f naught by mb. So we should have option B is the right answer. That is option number 2.